Okay, in this lesson we're going to talk about surface area of prisms and pyramids. So what is surface area? Okay, essentially what it is a two-dimensional measurement on a three-dimensional shape. So it's not three-dimensional, the measurement, but it's on 3D shapes. So one way to think about it is how much wrapping paper would it take to cover a 3D object? So like this box here, what if we wanted to wrap it up? That's a two-dimensional measurement because paper, right, flat paper like 2D, how much would it take to cover it, right, if we laid that all out flat? Another way to think about surface area is painting something. What would it take to paint each side of this box, right? Painting a flat surface like a square or rectangle is a two-dimensional measurement, right? But if we add all the sides up, that would be all the different sides on a 3D shape. Add them up, okay? So when we're doing surface area, we're still doing square. These aren't written out right. This should be like meters squared above it or centimeters squared. I don't know why there's, or kilometers squared, right? I don't know why we have this twice. Okay, so it's a two-dimensional measurement on a 3D shape. Now, here's where it gets a little tricky. If you go to your formula sheet, some of these surface area formulas, so now we're looking at the surface area formulas. We're gonna look at the ones, the same shapes we did in the previous lesson, the rectangular prism, the triangular prism, and the square base pyramid. They can get a little messy. I mean, look at this one for the square base pyramid, right? There's a lot going on there. Or the triangular prism, there's a lot going on here. I'm gonna tell you right now, they're not as complicated as they look. So what I'm gonna do when I do this, I generally ignore the formulas. Now, the only one that's pretty simple is the rectangular prism, but I don't even use the formula for that. Let me show you the best way to go about doing this, okay? So this is not me trying to be smart. This is how you should really understand how to do surface area. So for a rectangular prism, that's what this guy is. So I'm just gonna write REC, short for rectangular prism, right? How many sides does it have? It has 6 sides. So why don't we find the area of each side? So think about this. If we kind of draw, I'm gonna just try my best to draw out the back, you know, if we can see kind of what it looks like there. No, it's not perfect. All right, so let's start with the front. Like we got, you know, a front and back. So maybe I should get rid of this, okay? So we'll call this side A, okay? The front and back are the same. So I'm gonna write that down here. The front and the back, right? They're the same shape. They're both rectangles, right? So how are we gonna find the area of that? Well, think about it. We got area of this shape. Let me just draw it out, right? We got this rectangle and there's 2 of them. It's 12 by 14. Well, how do you find the area of any rectangle? Length times width, right? So all I gotta do is go 12 times 14, and that will give me the area of the front or back. And then I can times it by 2. Now I can do it at the very end, times everything by 2, or I can just do it right now. So let's get our calculator out and go, all right, well, what's 12 times 14? It's 168 millimeters squared. Now that's, again, why it's confusing, right? We're not filling this thing up. We're just painting or covering the outside. So the area of that rectangle is squared because it's a two-dimensional measurement. And then we can times it by 2, or we can just do it at the end and times them all by 2, okay? All right, why don't we do the sides here? I'll call this 2 here, okay? Or sorry, I'll call it B, part B here. All right, so that would be these sides here, right? And there's one on this side and one on the other side we can't see. So I'll call it the sides. All right, well, same thing. They're just rectangles, right? They're 11 by 12, right? 11 is that, and 12 is the height there, right? Because it's the same as what's over here. All right, so how are we gonna do the area of that? Same thing, length times width. So I'm trying to show you here, you already know how to do the area of all these things. You can find them just by using the normal formulas you know. This is just length times width, right? So 11 times 12, 132 millimeters squared. And then what about the top and bottom, right? So the top and bottom are the same. This would be this shape here. I'll call that part C. I'm just gonna label it so it's easy to follow along. So, you know, I meant to call this A. I meant to call this B. And top and bottom we'll just call C, part C. Top and bottom, right? So just find the area of those, right? Same thing. Well, what are our dimensions for our top and bottom? They are 14 across by 11 deep, so 14 by 11. Area again is just length times width, so 14 times 11 is gonna give us 154 millimeters squared. All right, now that's only 3 sides. Remember, there's 2 of each, so we have 2 choices. We can either multiply each of these by 2 and then add them up, or we can just add them all up and then times it by 2. So to get my surface area total, I'm just gonna write SA for surface area, although really A, it would make the most sense. It's an area, okay? It's gonna be 2 times 168 plus 132 plus 154. So add them all together, times it by 2 because there's 2 of each, and it looks like we get 908 millimeters squared. So the moral of the story here is, for those of you, that really want to learn this stuff, is you don't need the formula sheet for everything. When you get to surface area, try to use logic that you understand. Like, break it down. What shapes are there here? They're just all rectangles. You can find the area of a rectangle. All right, let's move on to the next one. All right, so our next shape is the same as our next shape from the previous lesson. It's a triangular base prism, or triangular prism, right? Triangular base or triangular prism, same thing. Now, how many sides does this have? Well, if I draw this in, let's just imagine it's clear and we can see through it, right? We'd have 2 triangles on the end, plus a bottom, a side, and a front. So there would be 5 sides altogether. Now, again, if you go to your formula sheet for this, this is where it gets really confusing. So if I come down here, see there's a lot going on. What do they want you to do? They want you to find the area of the base. They're basically explaining what I'm going to do with you, but it's a little more confusing. Find the area of the base, find the area of rectangles, add them all together. So really it's not too confusing, but there's a lot going on here. We don't have to make it that complex. Let's just go to the shape and say, all right, let's find the area of each part of these. So let's start, let's say part 1 here, or part A, right? I'm going to call these triangles in the front and back, okay? So the triangles, there's 2 of them, right? All right, so we got 2 triangles. Well, we know the formula for the area of a triangle. Isn't it base times height divided by 2? And then I'm going to times it by 2 because there's one here and there's one here, right? There's 2 of these triangles. So what we can do here is we can essentially just cancel these out, right? Dividing by 2 times them by 2, and all we got to do is multiply the base and height. So what's the base of our triangle? What's the height of our triangle? Well, the base of our triangle is 3. The height of our triangle is 4, so it's just going to be 3 times 4. Again, divided by 2, but times 2, and in the end, we just end up with 12 centimeters squared. All right, so now let's get to the rectangles, right? So let me just get rid of some of this stuff here. All right, let's talk, oops, I didn't mean to get rid of everything. Let me just draw my lines back in here. Not the best job, but it'll do. There we go. Okay, let's look at the bottom. I'll call the bottom part B, B for bottom. All right, B, the bottom rectangle, right? We know the formula for that. It's just a rectangle. So I'm really trying to push you to just use your own thinking instead of the formula. I'm not trying to make it harder on you. I'm trying to make it easier on you, right? So what do? 3 times 15, length times width. Because the formula is going to make you do this anyways, and it's just a little hard to read through. I want you to realize that you already know how to do this. All right, 45 centimeters squared. Let's do the back. Let's call this part C, that back triangle, or back rectangle, right? I'll just call it the back. All right, the part we can't see in our diagram, right? Well, again, it's just a rectangle. It's length times width. What are we going to multiply here, right? 4 times 15, all right? 4 times 15, that's easy. That's 60 centimeters squared. And finally, we need to get the front. So the front is this one here. So I don't know, we'll call that part D, I guess. All right, so part D. Oops, I called that last one 3. I'm getting sloppy here. That was supposed to be C. This is D, which is our front-facing one. All right, so again, area, length times width. Well, we got a problem here. We don't know, let me just get rid of some of this stuff, right? We don't know this length right here. So we got a problem. So what are we gonna have to use? And this is gonna come up a lot in questions. Pythagorean theorem, right? We don't know that. So let's do Pythagorean theorem here. We have a triangle that is 4 by 3 by, we don't know what this is, and that's the C in my triangle, right? So C squared equals A squared plus B squared. The other 2 sides are A and B. So 4 squared plus 3 squared. Well, if you square 4, you get 16. You square 3, you get 9. Add them together, you get 25. We got to take the square root of that to get rid of the square. Hey, the length is 5. That's how long this is. So there we go. So be aware, as soon as you see anything that involves a right angle triangle, there is a high probability, especially if we are in the classroom, a high probability of you having used Pythagorean theorem. All right, so we're back at it. What do we got here? 5 times 15, what's that going to be? 75. There we go. Centimeters, oops, centimeters squared. Nice job there. Okay, and now you got all the different areas. All you got to do is just get your total. Add them all up, right? What's our total going to be? Make sure we got everything. We got our 2 triangles here. That's 12. Plus the bottom and the back, 45. Plus 60 plus the 75. Add them all up, and our surface area is going to be 192 centimeters squared. Don't forget to include that centimeters squared, right? Even though it's a 3D shape, we're just finding the 2-dimensional exterior of this, right? What would it take to wrap this up? How many square centimeters of wrapping paper or something would we need, or paint, right? So when you go get paint at the store, if you're ever painting your house one day or that room, that's what they want to know. What's the square footage, or how much does it take to cover, right? So you measure the lengths and widths of your walls and you figure that out. All right, let's do one more shape here. All right, so our final shape is a pyramid, and the one we focus on the most is a square base pyramid. So I'm gonna write square base pyramid. All right, so how many sides does it have? Well, it's got one triangle on the bottom, or one square on the bottom, and then 4 triangles on the side. So there's 5 sides. Now again, if you go to your formula sheet, you can use it, but you may have a little bit of trouble. It's not too difficult, but they're showing how you have to find this, you have to find this, and then to get your total, you gotta find the different parts and add them together, right? To get your final formula. I completely ignore this formula. I'm just gonna go back here and let's use what we already know, because we can make this simpler than the formula makes it seem. So let's start with the bottom, right? The bottom is super simple. What shape is on the bottom? It's a square, right? So how are we gonna find the area of a square? Well, length times width, or length times length, you know, length squared. I always just write length times width, but length times length, right? 9.3 times 9.3, or you could just say 9.3 squared, right? Because that's what you get when you do that. Either way, let's punch that in our calculator and see what we get here. All right, so when I punch that in my calculator, I get 86.49. Let's keep those decimals for now. We'll round it at the end, right? Centimeters squared. Now, what about the sides? Think about it. What are the sides? They are triangles, right? Now, when you are doing this, remember previously when we talked about the difference between the slant and the height. Let me just jump to that. Okay. The slant versus the height. When you're doing volume, remember I doodled all of us in our previous lesson. Here, let's clean it up a bit. When you're doing volume, remember how you needed the height. When you're doing surface area, you need the slant, because we're only concerned about the area on the outside. So think about this triangle on the outside of this pyramid, right? We don't need this height here. We need the slant, because the slant is how high the triangle is. If you take that triangle off, pop it off, take it right off that shape and only think about it as a 2-dimensional measurement, the slant is the height of that triangle laying down sideways, okay? So we need the slant whenever we're doing surface area. So that's the big thing to remember with cones and pyramids. Surface area, you need the slant. Volume, you need the height. Okay, so let's get back to this here. We need the slant, and luckily that's what they gave us. How do I know it's the slant? See how that line they drew is going down the side of the triangle? If they had given me the height up the middle, I would have to use Pythagorean theorem, draw a little right angle triangle in there and figure it out. But in this case they didn't. So be aware of that. This is another case where you might have to use Pythagorean theorem. All right, so let's do it. So we have 4 triangles, right? All right, so 4 triangles. Well, what's the area of a triangle? Base times height divided by 2, and we're going to times it by 4. So now you can reduce that 4 and 2 if you want. I'm not too concerned about that right now. But those of you are like, wait, I just want to reduce that and go, all right, 4 divided by 2 is just 2. You can do that. That's fine. All right, so what is the length across? Think about my triangle here. Let me pull it out, right? Here's just looking at a side. It's 9.3 across, right? So that's our base, 9.3. The height of our triangle is the slant. We do not want the height of the pyramid. I can't stress this enough. And this is tough without being there with you guys to really break this down and show you some actual like 3D models that I have to really make sense of this, right? You want the slant. The slant height is what you want for this, because the slant height, again, think about it here, right? That is the height of the triangle. The triangle's been turned sideways like this, right? If this is my pyramid, right? It's been turned sideways. So it's been laid kind of at an angle, right, is really what I'm trying to say. So we want to use that 13.5. All right, so now it's just calculator time. What's 9.3 times 13.5 divided by 2 times by 4? All right, and I got 251.1 exactly centimeters squared. All right, so all we got to do is add it together. I got 4 triangles plus my bottom, right? Now be careful, when you're doing questions that involve pyramids, it's often that you don't include the bottom. That's the other thing I gotta warn you about, and that's where I'm trying to get at these things. There's often it's a question where it'll say someone's painting the outside of this thing, but they're not painting the bottom, right? What area do they need to cover? If you only use the formula off the formula sheet, you might get confused because it includes them both. Maybe we don't want this number at all. Maybe we don't want the bottom and all we want is this, right? So we have to be careful in the question. What do they want us to find? That's why I'm not using the formula. All these are so far is rectangles, squares, and triangles. And just find the area of the pieces you need and add them together. What if they only want to paint one side of this thing, right? That's what you need to watch out for. So I'm walking through the basics. What you really need to focus on is reading the questions carefully and what do they want us to find the area of. And it's usually just parts of these things, not the full shape. All right, so when I do that, I get 337.59 centimeters squared. All right, so keep those things in mind. You have to read the questions carefully. Sometimes you have to use Pythagorean theorem. Do I have the slant or do I have the true height, right? These are the things we want to focus on as we try these questions. All right, thank you.